Hi, welcome back to CMG-MathSpace. Let us now go through the following solved examples to explain further what we have discussed so far on sets and operations on sets. Mind you, after this particular episode, we will look at the steps or guidelines to solving two set problems and then three set problems. So this will serve as a preliminary questions for the upcoming episodes. Right. So if you check on this screen, right, we have this question which says that P and Q are subsets of the universal set U, where U is equal to 1 less than or equal to n less than or equal to 10, and n is an integer. P consists of multiples of 3 and Q of odd numbers. We have done this in so far, so let's do practicals if you can remember what we learned so far. So the first one says that we should draw a Venn diagram to illustrate U, P, and Q. And the next one says that list the number of the elements of A, right, P union Q, B, P intersection Q complement C into P intersection Q, all complements. Then from there, if a number is chosen at random from U, what is the probability that it belongs to into P intersection Q or complements? Now, this is the solution. So we are saying that I'm actually giving you steps. So that's why I'm not worried about solving some particular problem or maybe writing them down, but we are going to check from the textbook directly. So we are noting that when sets are described, it is always advisable to list their members first. Now listing the members of U, P, Q, blah blah blah. I've told you whenever you are given such a question, relax and write them down. So here we have U. Now anytime you see U here is a universal set. Everything under the set or under the problem that we are discussing. So U encompasses everything. Now we have U to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why? Because we were saying that 1 less than or equal to n less than or equal to. So it means that all the extremes of the sets are involved. So 1 is part and 10 is part. Now when you move to P of multiples of 3, we know multiples of 3 starting from 3, 6, and 9. Why is the limit from here? Because odd numbers and the multiples of what? The P, it starts from 3. So even though from the universal set we have 1, 2, 3 up to 10, there's a limit, there's a constraint here. So 3 starts from the multiples of 3. Then it will end at 9. Why? Because that's the limit. 10 is an even number. You get the point. Now Q also says that we are looking at where is it? P says that Q of odd numbers. So 1 inclusive. So 1, 3, 5, 7, 9, and then 10 is not part. 10 is an even number. So you get a point. So that is why this is. So first of all, you have to get this right. If you don't get it right, then you are wrong from the onset. So make sure you understand every part of the question, right? So now that you have this, then you are good to go. Now for the representation, we have it here. We have anytime you see a circle like this, right? P encompasses everything from here and here. Here means only this portion is only P. And then if you take Q only here, and here is only Q. But stating everything under Q means the intersection is part. Stating everything under P means everything is included. So that is the idea, what you have to take home. So P only is different from P, and Q only also is different from Q, right? So if you have that understanding, then we can do the listing here. Now we have here. So here means that everything that is in U but not in in P. This is what it means. Everything in U but not in P, and everything in U and not in Q. This is how this is represented. So if you do the calculation, you understand. We have said something about this earlier. So we only said everything here This is the U, everything in the box, in the outside or the circles. So if you say, if you are setting this, it means that everything in U but not in Q. In the same way, everything in U and not in P. So this is what we have. This is what you have here. Don't worry. Let's go and then we understand it. I'm giving the theoretical aspect. Now that we have seen this, now let's look at I. Looking for P union what? Q. You lace them. It's a matter of joining them. Everything that you have in P, everything that you have in U, you join them, and then you have that. And this will be different from the universal sets, if you have the point. Now let's look at B intersection Q complement. We told you anytime you have Q complement in a problem, what you have to do first is to look for the complement first. After finding the complement, then you do the other combination that you have to deal with. So if you are looking for Q complement is, this is it. And what does Q complement mean? I've told you earlier that if you are looking for Q complement, it means that everything in set U, but not in what? In Q. So you have to consider this set, U set, and then Q set. Then things that are here but not here, you see that this is the set 2, 4, 6, 8, 10. So if you were the other way around, asked to find P complement 2, it means that everything here but not in P, right? Then you have the list, right? But here you've been asked to look for Q complement. So everything in U but not in Q, and we have 2, 4, 6, 8, 10. Now that we have this set, now you combine them with the intersection. So you combine this and this, look for what is appearing here and appearing here at the same time. So you can see that 6 is here, 6 is here. Apart from that, there's nothing occurring again. So that's the idea. And now we have some note to take home. To find P intersection Q or complement, first find P intersection Q. That's the bracket first, and then blah blah blah. So after looking for that one, then we see that. So now let's move to P intersection Q. We have that with the set that we have defined. You have 3 and 9. Now come again, P intersection Q or complements. Everything. So here too, everything in U, but not in P intersection Q. It's as simple as that. I think you have gotten the point. So now let's move to the other side of the question, which is asking that point 3 is asking that if a number is chosen at random from U, what is the probability that it belongs to P intersection Q or complements, right? So anytime you see n means the number of elements in that intersection, n, this small n, the number of element in that set's number. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8. You have 8 there. Now look for the universal set. Everything in U, we had 10 numbers. We listed from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's why you have 10 here. Then P intersection Q or complement, we had 9 elements. So this is ratio. You cancel out, cancel down. We have 4/5. So this is as simple as that. We are taking notes. So this is it. So now, thank you very much for watching. Take your time be pausing the video. This is if you're new on the channel, this is AKI-OLA core math series for SHS students. I am using edition 5, page 18. If you are using the same edition, you have the same thing. If you are not using a different edition, you just follow through and you see this particular question somewhere along the pages, right? So we'll see you in the next one where we tackle 2 set problems, and then the next video will also be 3 set problems. We are giving the guidelines into solving these problems. So we will see you in the next one. If you have any question, drop in the comment section, and then please like and follow. Let's just hit 1K so I can start live where I'll be dealing with questions. You ask questions, particular problems. I can be solving more questions instead of just giving the guidelines. So we'll see you in the next one. Bye for now.